In this video, I'm going to talk about fillets and chamfers. So fillets and chamfers are ways you can modify the edges of your 3D model. I'm going to go ahead and start with fillets. I really like fillets because what they do is they just round off hard edges. This is great from a practical standpoint because if you're machining or 3D printing a part, your finished part could have some very sharp edges and corners that you could hurt yourself on. So by applying a fillet, you round off those edges, so you aren't as likely to, get yourself cut or poke yourself. So for fillets, you can select an individual edge and move the slider around. That's the basic fillet right there, and you can see it just rounds off the edge like that. So you can use the arrow slider, you can type a value here. There's a couple different radius types you can use if you really wanted to, but I've only ever used constant, so you're probably okay just doing that. So I'll just hit OK. There's my fillet. Here, let's try a corner. So I'm going to go back up here, click on the fillet button again, select 3 edges that make a corner, and then I'll run the slider again. Just like this. You see, rounds off 3 edges into a corner, just like that. And there's a couple corners you can set. This is what's referred to as a rolling ball corner. If you choose a setback corner, it makes the corner just bigger, but it's still round. Oops, it just gave me an error. I filleted, made too big of a fillet, so I'll leave it like that. There's this other thing here called tangency weight, which affects the curvature of the fillet. So I'll zoom in here so you can see a little better. And you can actually control tangency weight here with a slider. So right now the default's at 1, but if I make it bigger, which is up to 2, the ends of the curve are flatter relative to the flat surfaces that they meet. Whereas if I slide the other way and make it more 0, it actually turns these curves into, I think they're pretty much flat. They're basically chamfers at this point. However, the corner's still round, and it automatically turns the corner into a setback, which I think is kind of interesting, but that's the way it works. Yeah, because if you set to 0, okay, well that's interesting too. If you, I just set to 0, and now we have hard corners about 0.1. Yeah, it still changes it to a setback on its own. I'll bring it back to 1. So do fillets like that. If you want to apply a fillet to every edge of a flat surface, all you have to do is go click on fillet. Actually click on the surface, then you can use the arrow here to apply a fillet to all the edges affected by that surface. The holes, this thing. Yeah, just like that. So now this is where I get into more of an engineering aspect of fillets. Not only do they make sharp surfaces rounded so you don't hurt yourself on them, but fillets are also pretty important to apply to inside corners, like this one right here. What happens, especially with brackets like this, is that stress on the bracket could snap it in half. Especially at this corner right here, all the stress on the bracket concentrates here, where it bends at this sharp corner. Just snap it in half. So to mitigate that, you can apply a fillet to this inside corner, just like that, and that gives the stress on the bracket a longer path to apply itself. So instead of just focusing on this one little point here at a 90-degree corner, the stress flows along a greater distance. So it's more spread out. Your bracket isn't as likely to fail then. So that's an important design consideration right there. Now let's talk about chamfers. So a chamfer takes an edge and splits it up into two edges connected by generally an angled flat surface. So let's go back up here. For this, I click on the modify button here and select chamfer. Now select an edge here. And there's three different types of chamfers. I'll start with equal distance. So that basically means when I slide the arrow down, vertical and horizontal move symmetrically. So that's an equal distance chamfer. There's also a two distance chamfer where you don't have to keep your chamfer symmetric. You can make your chamfer as deep or as shallow as you want, as steep or as shallow as you want, I should say. Just like that. And there's also, I'll create another chamfer here. I'll highlight the edge first. A distance and angle, so you can select what distance you want the chamfer to go, and then instead of it being a 45-degree angle like you have with a symmetrical chamfer, you could adjust it to make it as, okay, I guess I can't really demonstrate it here well because the fillets are interfering. Let's fix that. I'm going to get rid of some of these fillets by deleting them from the timeline, so I can properly demonstrate this chamfer. So I'll highlight the edge, distance and angle. So yeah, you can slide the arrow down distance and adjust the angle of the chamfer with this slider here. Yeah, because I'm pretty sure with the angle at 45 degrees, it's the same as an equal distance chamfer, then just the angle like that. And there's different kinds of corner types for chamfers. So let's try this again at a different corner, like we had a fillet set up. So let's set this up for a chamfer. So we do this. Oh, you know what? I gotta set to equal distance to keep it from yelling at me. There we go. So yeah. So one of the reasons that I don't like chamfers, for, I guess kind of dulling edges, is that it just creates two more potentially sharp edges, and in this case, creates two more corners too that you could poke yourself on. But anyway, let's talk about corner types. So there's different corner types here. This is a chamfer corner type. Here's a miter, which it makes a really pokey corner right there. And then there's a blend. I think that's pretty cool. I guess it's supposed to kind of blend a miter corner and a chamfer corner together. Make this big flat corner thing. Just like that. See if there's anything else that we can do with this. I'm going to get rid of this other fillet while I'm at it, in case it interferes with something. So let's create another chamfer over here. There's this tangent chain. I'm not sure what exactly that does. That's not something I've really messed with at all. I'm not going to even worry about it. I'll just cancel that. One thing I do find chamfers really useful for is for creating, I believe they're referred to as countersunk holes. So if you have like a flat top screw that you want to drive into this bracket and make the top of the screw flush the bracket, that's would be useful to add a chamfer to one of these, to a circular edge of the hole, and add a chamfer, or I guess this would actually be a bevel, I think. Whatever it is, you add the slope to the surface there so that the flat top screw can go into the hole and have its top be flush with the surface you're screwing into. And just like selecting a face to apply a fillet to all the connected edges, you can do the same thing with a chamfer. Select the face and apply a chamfer to all edges associated with that face. Now personally, I like to use fillets for for structural purposes. I also like using them for artistic purposes too. When I'm doing like models, I really want some rounded edges and stuff. They're great for that. Make things aerodynamic, I suppose. But when I'm printing parts too, and I really want to take advantage of a fillet, that's for stress purposes. They're good for that. Chamfers I usually use solely for artistic purposes. If I really need a slanted edge for something, I want to adjust the angle of it too. I really want a sloped edge or surface. I find chamfer really useful for that. You should also be able to apply fillets to chamfered edges and corners. Yeah, just like that. So you could combine fillets and chamfers so you can round off the edges that chamfers make as well as the corners. Let's see here, because I'm actually curious now how one of those chamfers with a blended corner would turn out. So let's see here. Chamfer. Oops. Yeah, I have a blended face. Okay, that's fine. Let's see. Let's try doing a fillet here. Oops. I don't know how that even got selected. I just want to select these faces. I kind of want to see what happens. And Fusion 360 gives me a ton of errors. Okay. Maybe it won't work the way I want it to. Why does it keep selecting that invisible thing? I don't understand. Come on, let me do the fillet here. See, yeah, check that out. You could do some interesting things too, combining fillets and chamfers, like this interesting looking rounded corner flat thing. So, yeah, there you go. It's fillets and chamfers and how you can apply them to models. You can get creative with them. And again, I think there's, from an engineering standpoint, there's probably more value to fillets than chamfers. Also from a handling standpoint, so you aren't poking or scratching, cutting yourself on hard edges and stuff. So, there you go. Fillets and chamfers. There's one other note I want to make about adding fillets to models you're going to 3D print. I'll just re-add the one I had here. I believe I mentioned earlier that fillets and inside corners allow for stress at set corners to spread out as opposed to being focused on like a hard 90-degree inside edge where a part could easily fail or snap apart right there. So fillets are great for spreading that stress out along a farther distance so that a part isn't as likely to fail there. But when it comes to 3D printing, to truly take advantage of a fillet's function in that manner, you have to print your part so that your fillet is perpendicular to the print bed. So your part can't look like this on the print bed. It actually needs to look more like this. Like this, with your fillet perpendicular to the bed, because you want your layers to print along the fillet. So your print head's going along this edge and then around the fillet, and just print all your layers just like that. That's how you can take advantage of that fillet in your 3D print. Whereas if you printed it, your regular home facing on your print bed, your layer lines are going to go just right through your fillet, and it's just going to snap at the layer line or shear right there. Because that's what happens with layer lines. They're more susceptible to shear, parallel to the layer lines. That's just the way most consumer 3D printers work. Depositing the layers one on top of the other. The bond is a lot weaker there than the continuous streams of plastic that make up those layers. So that's just something to keep in mind when you're printing your part and you really want to take advantage of a fillet. Make sure that fillet is printed perpendicular to the bed. Thank you for watching this video. If you liked it, please be sure to click the like and subscribe buttons below. Also, post any questions you have in the comments and I may answer them in another video. And remember, anyone who stops learning is old, whether at 20 or 80. Anyone who keeps learning stays young. So keep learning, keep designing, keep making, and be proud of your work.